This section deals with combining functions. And so I'm going to show you how to combine functions by starting with an example. And in this example, we have two functions. F of x equals 3x minus 5, and g of x equals 3 plus x. Now, if I want to find f plus g of x, that is defined to be f of x plus g of x. So this notation just tells you that you take each separate function and add them together. Here's my f of x, and here's my g of x. And then we combine like terms. 3x plus x is 4x, and negative 5 plus 3 is plus 2. So our solution is 4x plus 2. Our next problem says find f minus g of x. Well, by definition, f minus g of x equals f of x minus g of x. So we're going to take our f of x function, which is 3x minus 5, and we're going to subtract our g of x function, which is 3 plus x. Now, when you subtract, you need to distribute the negative sign through the second function. So this really becomes 3x minus 5 minus 3 minus x. And then we can combine our like terms. 3x minus x is 2x, and negative 5 minus 3 is negative 8. So be real careful when you do your subtraction that you distribute that negative sign through. Now f times g of x means f of x times g of x. So all we do is we multiply the first function times the second function. Now when you multiply two functions like that, you use the FOIL method. And so I will just use my FOIL method. 3x times 3 is 9x. 3x times x is 3x squared. Negative 5 times 3 is negative 15. And negative 5 times x is negative 5x. And I will rewrite my problem in descending powers of x. So I'll have 3x squared, and 9x minus 5x is 4x, and then we have our minus 15. So that is f times g of x. Now before we continue, I want you to recognize that all three of these solutions do not have fractions, and they do not have even radicals. Therefore, the domain of all of these three is minus infinity to infinity. Okay, our last one for this particular set of functions is f divided by g of x. And by definition, that means f of x divided by g of x. So my f of x was 3x minus 5, and my g of x was 3 plus x. There's my solution. Now the domain differs on this one because we have a fraction. And remember, when we have a fraction, we have to eliminate from the domain the number that gives a 0 in the denominator. Well, 3 plus what number equals 0? That's negative 3. So x cannot equal negative 3. And our domain, written in interval notation, would be minus infinity to minus 3 union minus 3 to infinity.